Hello everyone, and welcome to this video on AI, machine learning, and the Relative Strength Index Indicator, or RSI for short, and Python. So in this video, I will use the RSI trade indicator to train an AI model to predict the best times to buy and sell Bitcoin. And I'm going to try to choose the best model for this prediction. Now, before we begin, if you like the videos on this channel, then be sure to click that subscribe and like button. And to be notified about new videos from this channel, hit that bell notification. Also, you can get the code or dataset or just support the channel on Patreon at patreon.com/computerscience, and I will leave a link for that in the description below. And also, the material in this video is purely educational and should not be taken as professional investment advice, so be sure to invest at your own discretion. Alright, so with all that being said, let's get started. I'm currently on Google's website. It's called colab.research.google.com, and I'm on it because it makes it easy to start programming in Python. So if you're going to code along with me, go ahead and go to this website. Then click on File, click on New Notebook, where a new tab will open up for you, and then eventually a new cell will open up for you. So I'm just going to give it a little bit of time here. Okay, so we can see that it has loaded up. The first thing that I'm going to do is I'm going to import the libraries that I plan on using throughout this program. So I'm going to import numpy as np. I'm going to import pandas as pd, and then from sklearn.ensemble, I'm going to import random forest classifier. All right, also from sklearn, but this time sklearn.svm, I'm going to import svc, which stands for support vector classifier. All right, and that's a support vector machine model. All right, so next from sklearn.linear_model, I'm going to import logistic regression. And then from sklearn.model_selection, I'm going to import train_test_split. All right, so that should do it for my libraries. I'm going to go ahead and run this by clicking that button here to the left, and this will let me know if I made any mistakes. Okay, so it looks like it's almost done, and I'm good. So I'm going to create a new cell by clicking that code button in the top left. And now in this cell, I'm going to create a function to get the relative strength index values, or RSI for short. So I'm going to call this function RSI. It's going to take in some data. It's going to take in some time period that I'm going to set equal to 14 for now. It's going to take in some column. For now, it will be the close price of the cryptocurrency, Bitcoin in this case, or any asset really. And then I'm going to get the moving average. I'm going to call it MA for short, and I'm going to set it to SMA, which will stand for a simple moving average. Okay. All right. So that's the parameters there. Let's create a variable called delta. Delta stands for change or difference, right? So delta will be equal to data column. So we're going to get our data and the column, and we're going to get the difference. So I'm going to put dot diff 1, and I'm using diff function to find the discrete difference over the column axis with period value equal to 1. Also, I can get rid of that 1 and it'd be the same thing because it's defaulted. All right, so next I'm going to put delta equals delta dot drop in a, so I can remove any NA values. Then I want to make a copy of delta, so I'm going to create a variable called up, and I'm going to set it equal to delta dot copy. And I want another copy, so I'm going to call it down. I'm going to set it equal to delta dot copy as well. Okay, so right now I'm making a copy of the objects, indices, and data. All right, now I want up to contain only values that are greater than or equal to 0. So if up is less than 0, I'm going to set any value in up equal to 0. All right. And for down, I want to get all of the values in down that are, no, I want to set all the values in down that are greater than 0 equal to 0. Okay, so we're going to get everything that's 0 or less, right? Okay, so I think that's correct. Let's go ahead and continue here. Next, because of this MA parameter that I have, I'm going to make it such that it's optional to choose our moving average. So if MA, which is short again for moving average, is equal to SMA, which is simple moving average, then the average gain will be equal to up dot rolling window equal to our time period, and I want the mean. All right, I think that looks good. Next, let's get the average loss. So average loss, I'm going to set it equal to the absolute value of down dot rolling window, basically the same thing like I did up top, time underscore period dot dot mean. Okay, and that should do it there. All right. Okay, so that will get us the simple moving average. Else if MA is equal to, let's do something like EMA, the exponential moving average, then it's going to be almost the same. It's going to be a little different. Okay, so here I'm just going to put average underscore gain. I want to set it equal to up dot EWM, and then span is going to be equal to our time period. Okay, and adjust will be equal to false, and then I want the mean, so I'm going to put dot mean here. Let's see, time period. Okay, I'm just going to highlight all this right here, copy, use Control C. I'm going to press enter, and I'm going to calculate the average loss to be equal to the absolute value, and I'm going to paste everything in here. Okay, and then I'm going to just change this up value to be down. Okay, so this will allow me to use two different moving averages if I wanted to for this RSI function. All right, so now let's get the RS, the relative strength. So I'm going to set it equal to the average gain divided by the average loss, which is the actual formula calculation. All right, next I'm going to get the RSI now, the relative strength index, by setting it equal to 100 minus 100 divided by 1 plus RS. Okay, and that should be the formula. Okay, and now I'm going to go ahead and just create a column in the data set, and it's going to be called RSI, and then I'm going to append a string to it, and the string will be the time period. All right, and you know what, I'm going to add something else. Let's or append something else. So I'm going to append underscore plus string MA, so I know what moving average I'm using also. All right, and I'm going to set this to RSI. So I need to make this underscore a string, so I'm going to put quotations around it, and that should do it for our function. Let's go ahead and run this. Okay, it looks good. I hope everything there is correct. All right, so next I'm going to create a function to select the best model to use. Okay, so I'm going to call this function select underscore best underscore model, and it's going to take in a X train data set and a Y train data set. Okay, so we're just going to take in some training data, right? And then based off this training data, I'm going to choose the best model. So I'm going to create a list of machine learning models. So I'm going to create a list of models. So I'm going to create a variable called models and set it equal to a list. All right. And now within this list, I'm going to input our models. So I'm going to put in the random forest classifier model. And I'm going to put in the support vector classifier model. And then last but not least, I'm going to put in the logistic regression model. Okay, so now I have my models, and you can add more to that list if you want to. Next, I want to evaluate each model on the training data sets, or the training data set. So I'm going to create a variable called model score, which will help me to evaluate each model. I'm going to set it equal to an empty list, and it's going to contain all of the model scores, right? I'm going to append the model scores values and the models to this model scores list. All right, so that'll help me to figure out which model is indeed the best model based off of the training data. All right, so let's go ahead and loop through the models. So for model and models, so for each model in our models list, I'm going to do model.fit, which is another name for train. Fit is another name for train. So we're going to train the models, or this specific model, on X underscore train data set and Y underscore train data set, which we got from our parameters. All right, next I want to calculate the accuracy of the model. So I'm going to create a variable called score and set it equal to model.score, and we're going to get the score of the model on the training data set. So that's on X train and on Y train. All right, and then I want to append the model and the scores to that model underscore score list. So we're going to append the model and its score. Okay, and let's see, it should just be score. All right, so I think that'll do it. And then last but not least, we need to actually get the best model and then return it. So let's select the model with the highest score. So I'm going to create a variable called best underscore model. I'm going to set it equal to max, so we can get the model with the max score. We're going to input model scores, or model score. You know what, actually I'm going to change this to scores. I'm going to put an S here, okay, because it contains many scores, right? So it just makes sense for me. So max model underscore scores, and I'm going to set the key to be equal to lambda x colon x at position 1, and then I want to return only the model at position 0. Okay, so what I'm doing here is I'm finding the max key element that we will call x at position 1, which is the score, and then I'm going to return the model at position 0 of this tuple or tuple. Okay, so I hope that made sense. Let's go ahead and return the best underscore model, and let's run this. All right, let's create a new cell. So hopefully you all understand what we've done so far. So far so far, we have created the RSI function to get our RSI values. We've created a function to select the best model out of 3 different models for our machine learning model and to make future predictions. So now we're going to get the best model, and now it's time to put it all together. So we're going to need the data set, so we're going to load the data. So I'm going to create a variable called df, which will be short for data frame. I'm going to set it equal to pd.read_csv, and we're going to read in a btc.csv file, and I just need to go ahead and upload that. So I'm just going to click this little icon here, click upload here, and I'm going to click this btc file. So now I have my btc.csv file, and I can exit this here. And so now that should be good. Let's just run it just to kind of test it. Okay, so it's good. Next, I want to create a new column in our data frame, which is df. And I'm going to create a new column called percentage change. And I'll make it a capital P, percentage change. Okay, so let's go ahead and create this new column called percentage change and set it equal to df. I'm going to use the close price df.pct_change, which, if you've guessed it, is percentage change. All right, and now I have this daily percentage change of the price of Bitcoin. And you know, we didn't take a look at all at the file here. So I'm just going to come over here. I'm just going to double click this, exit this, and here I can easily show you what's in this btc.csv file. All right, so we can see we have our open column, high column, low column, close column, just a close column. We have the volume and the date. Okay, so we have a lot of data in here. It looks like we have 1,837 entries. So this is the data set, and the percentage change in this case will be the percentage change from one day to the next day, right? Did it go up or did it go down the next day, right, in value based off of the close price? So that's what the percentage change is going to be here. All right, so hopefully that was understandable. Let's go ahead and let's continue. So I'm going to create another column. So now I'm going to create a column to get the buy and sell signals. So when the price goes, or when the price went up, we should have bought before, and when the price went down, we should have sold before, right? So I'm going to create a column called signal, and here I'm just going to put some comments here. Create a buy and sell signal. So I want the buy signal to be equal to 1. So 1 will be buy and -1 will be sell. That's what I'm going to put in this column. All right, so let's call the column signal. All right, and let's go ahead and create this. So the signal will be np.where, where the percentage change is greater than or equal to 0, then I want to buy, else I should have sold. So 1 for buy, -1 for sell. All right, I think that'll do it. There may be some issues there. I have to think about that. For now, let's go ahead and continue. Let's drop NA. So we're going to drop any NA or NaN values, and I'm going to do it in place. So I want it to do this on the data set itself. So we're going to remove all those nan values. Okay, and let's create some more columns. So we're going to create some RSI columns. So the whole idea here is to use the RSI indicator to then come up with a model that can tell us when to buy and when to sell. And so we can use the RSI indicator in different ways because we can put in different values for the parameter, right? So we can we can use the simple moving average, we can use the exponential moving average, we can change our time periods, we can change our columns, all those type of things. So let's go ahead and create some RSI columns, and that's easy enough just by calling our RSI function. We're going to input our dataset df. I'm going to make the time period 6 days, and then the moving average that I'm going to use will be the simple moving average, or SMA for short. And then I'm just going to come here, I'm going to highlight all of this, I'm going to copy using Control C, I'm going to come down here and paste it using Control V. I'm going to only change the day to be 2, and so this will give me 2 columns for our RSI indicators. So one is using 6 days and the other one is using 2 days. Okay, and if we need more, we will create more. But for now, I think we're good. And you can experiment with this. You can input more, input less, add parameters, add different columns, whatever you want to do for your RSI indicators. Right, this is just a fun little project here. So anyways, I think we're good there. Next, I'm going to go ahead and I'm going to drop any NA values. So just put df.drop NA in place equal to true. Okay. All right. So now let me think here. So now we have used our function to create the RSI columns, right? So in our function, the columns will be named, let's see, it will be named RSI, and then it's going to have the time period. So in this case, RSI 6, and then an underscore, and then the MA that we're using. So it's going to have underscore SMA. All right. So we have 2 new columns that are similar to that. One will just have a 6, the other one will have a 2 in the naming convention. All right, so let's go ahead and create the buy and sell and hold signals. And we're going to create these based off of the RSI columns. Okay, so here I'm going to put based on the RSI values for RSI 6 underscore SMA and RSI 2 underscore SMA. All right, because those are the 2 columns that we were able to create here. All right, so hopefully I haven't lost you all. So let's go ahead and create 2 new columns. So one I'm going to call RSI 6 underscore signal, and I'm going to set this equal to np dot where df RSI 6 underscore SMA is less than or equal to 10. And this is because our RSI signals will be values between 0 and 100. So in this case, and in most of the RSI indicators, if the value goes below 10, then that's an indication that it's a good time to buy an asset because it is oversold. And anytime it's over 90, it's a good time to, or it's an indicator that it's a good time to sell the asset because it's overbought. All right. So I'm going to use 10 and 90 here. So anyways, if that indicator, if that RSI 6 value is less than or equal to 10, I'm going to say it's an indication to buy. Otherwise, I'm just going to hold. So I'm going to put a 0 here for hold. Okay. So let me see, create the buy 1 and sell -1 and hold signal. So hold will be 0. Okay. All right. So also, like I said, I want to get this sell signals. So I'm just gonna highlight. I'm gonna highlight all of this. I'm gonna copy it using Control C. I'm gonna come down here and paste it using Control V, and we're gonna change just a few things. So np.where, all right, RSI 6 underscore SMA is greater than or equal to 90. Then I want to sell. Otherwise, I'm just going to put whatever value is already there. RSI 6 underscore signal. Okay. And I think that'll do it for the RSI 6. Now we have to do the same thing for RSI 2. So I'm just going to come here. I'm going to copy all of this, or highlight it and then copy using Control C, and then come down here and paste it using Control V and change just a few things. Instead of 6 here, we're going to put 2. Instead of 6 here, we're going to put 2. And instead of 6 here, we're going to put 2. And instead of 6 here, we're going to put 2. And instead of 6 here, we're going to put 2. And then that should do it. Okay. All right. So let's continue. Let's set the index to be the date field. So I'm just going to type df.set underscore index, and we're going to take the date from the date column, and now that will be the index for our data frame df. All right, next I'm going to drop the date column from our data set. So I'm going to type df.drop, and I'm going to tell it to drop the date on the column axis. So that's axis equal to 1. And I want to do this in place. I want it to happen on this data set df. And so I'm going to set in place equal to true. And I think this is a good time to just kind of show the data. So let's show the data. I'm going to just print df, and let's run this and let's see what we've done. All right, so we have our original data set with the open price, the high price, the low price, the close price, the adjusted close price, and the volume, which we saw that earlier. And then we have a few more columns that we've added and created, which are the percentage change, the signal, which we're going to use for the target value for our machine learning model. We have our RSI 16 SMA column. We have our RSI 2 SMA column. And then we have the 2 columns that we just created for the signals, for our buy and sell signals, based off of the RSI 2 SMA and RSI 6 SMA columns. Okay. All right. So let's go ahead and create a new cell. And now I want to get the features to train and test on. Okay. So and also I want to get the target. So and the target data set to predict/classify. All right, so I'm going to create a variable called features, which will contain a list of our columns or features that we want to keep. So I want to keep the volume from our data set. I want to keep the close price column. I want the RSI 6 underscore signal column that was created, and the RSI 2 underscore signal column that was created. So out of the data set, I'm only going to keep these 4 columns, and these 4 columns are the features that I'm going to train the model on. Okay, and then the target is the signal target, right? So that tells us when to, or when we should have bought and when we should have sold, right? So I'm going to create a variable called x. I'm going to set it equal to df features, and y equal to df target. Okay. Next, I'm going to split the data set into 80% training and 20% testing. Okay. And then I'm going to use something called random state to control the random number generator used to split the data so that the splits are reproducible. So I'm going to create a variable called x underscore train and x underscore test and y underscore train and y underscore test. And I'm going to set this equal to train underscore test underscore split, and we're going to input x, we're going to input y. We're going to input our test size, which will be 20% or 0.20, and then I'm going to input the random state, which I'm going to set equal to 0. Okay, and again, that's so that we can easily reproduce this. All right. Next, I'm going to select the best model to use. So I'm going to create a variable called best underscore model. I'm going to set it equal to select underscore best underscore model, and I'm going to input x underscore train data set and the y train data set. Okay, then I'm going to evaluate the best model on the test data set, and I'm going to get the model's predictions. So I'm going to create a variable called, and maybe I just put that here, evaluate the best model on the test data and get the model's predictions / classification. Okay, so I'm going to create a variable called y underscore pred, which will be short for y prediction. I'm going to set it equal to best underscore model dot predict, and it's going to take in the test data, which we called x test, and then I want to calculate the score of the model. So I'm going to create a variable called score. I'm going to set it equal to best underscore model dot score x underscore test and then y underscore test. Okay, so now we're going to see how well it did with its predictions based on the actual values from y test. Okay, next I want to print the accuracy. So accuracy of the best model based on the test data, we'll have this score. So I'm printing the accuracy of the best model on the test data. All right, so let's give this a try. This should be it right here. Let's go ahead and run this and let's see what we get. Looks like there are a few mistakes here. Okay. All right, so let's go back up and let's see what's going on. So is something wrong with our features? So let's go back up here, features. We are going to get rid of this colon here. So my mistake there. They should just be features without it becoming a string. And let's run this now. Okay, so now that I've ran this model again, it looks like the accuracy of the best model is 71.58%, and that's pretty decent for this little quick fun project. And I hope that you all really enjoyed this. It's really cool that it chose the best model out of those three. We could check and see which one that is just by doing a little print statement if you want to. But for now, we can see that it chose, one of the best models, and based off of that best models training on the train data, we get 71.58% accuracy based off of the test data. So thank you all for watching, and a special thanks to the Patreon supporters on patreon.com. Again, if you would like to become a supporter of this channel or get the code or just get the data sets, then I will leave a link to the Patreon page, which is patreon.com/computerscience, in the description below. Again, remember that this is just a fun project, and I really hope you all enjoyed it. Thanks for watching, and I hope you all have a great day. I will see you all in the next video.